This is Gerald Combs. Today I'm going to show you how to get up and running with Wireshark by doing a simple network capture and using display filters. For this video, I'll assume that you know how to run the Wireshark installer and click the next button a bunch of times, so I'll skip over that and jump right in. The first thing you see when you run Wireshark is a nice startup screen that makes a lot of common tasks easier. If you've worked with any capture files recently, they'll show up in the center of the screen. Just below that, you can go to the collection of sample captures on the Wireshark wiki. Other links will take you to different parts of the Wireshark website. If you want really fine-grained control over the behavior of a capture, you can click on the Capture Options link. However, I don't need to set any options, so I can start capturing immediately by clicking on one of the interfaces in the list. I selected an Air PCAP adapter, and now we'll see a bunch of wireless traffic. Wireshark's purpose is to capture network traffic and to show it to you in a form that humans can read. The top part of the window is called the packet list. Each item represents a single packet that was captured on the network. The middle part of the window is the packet detail. Wireshark will show you as much as it can about the selected packet here. The bottom part shows the bytes in the current packet. There's no telling what will show up in a live capture during a demonstration, so in a desperate act to save myself from embarrassment, I'm going to click on the little stop icon and close the capture by clicking on the X icon. Next, I will open a carefully rigged demonstration file that has some HTTP traffic. You can see that different packets are shown in different colors in the packet list. Wireshark has a feature called coloring rules that determines what color is applied to each packet. By default, DNS packets are colored blue and HTTP is colored green. There's a GET request in the packet list. When I click on it, the packet detail shows the Ethernet, IP, TCP, and other information in the packet detail. If I click on the Hypertext Transfer Protocol item, I can see the headers that were sent in the GET request. Now watch what happens when I expand the Internet Protocol item and select the different header fields. Notice how different parts of the packet bytes are highlighted? That goes both ways. I can click on the packet bytes and then the corresponding protocol field is highlighted. Now I'm going to scroll down a bit and see if there are any interesting packets in the capture. Hey, look at that! Those packets look angry. If we expand the frame field on one of the packets, we can see some general information about it. One of the things listed is the coloring rule that was applied. This rule is named Bad TCP. Wireshark's default coloring rules are designed to help you quickly identify the different kinds of traffic in a capture as well as highlight potential problems. In this case, a packet arrived out of order and triggered a couple of warnings. If I right-click on a packet list item, I get a menu that lets me do all sorts of cool things. If I right-click on a detail item, I have even more options. I'm going to select Follow TCP Stream, which is available in both menus. This gives me a window that shows the conversation between the web browser and the server. The browser request is shown in red and the server response is shown in blue. Now I'm going to close the TCP Stream window. It looks like there are fewer packets than we had before. If we look at the status bar at the bottom of the window, we can see that out of 121 packets, only 20 are being shown right now. Why is that? Wireshark lets you trim down the packet list using a feature called display filters. The current display filter is shown at the top of the window. When I opened the TCP stream window earlier, it applied a display filter that shows only the packets that make up that particular stream. One way to create a display filter is simply to type it in. For instance, I can type in the word DNS to see just DNS packets. Before I hit enter and apply the filter, let's back up and take a look at that again. As soon as I type something, Wireshark tries to figure out if it is a valid display filter. D by itself isn't, so it shows the filter with a red background. Below that, it shows a list of valid filters that start with the letter D. When I type N, the filter is still red because that's still not valid, but the filter options are trimmed down a bit. When I type S, the filter turns green because that's a valid display filter. Now I can hit enter and apply it. Now typing this stuff in is all well and good for someone who knows what it should look like. Now I'm going to clear the display filter and show you an easier way to apply them. Watch what happens when I go to the packet list and click on the IP source address. At the bottom of the window, in the status bar, we can see detailed information about that field. The text in parentheses is the display filter name for that field. To use this filter, I could type in ip.src manually at the top of the screen, but I can also right-click on the field and tell Wireshark to apply it for me. I can filter on just about anything in the packet detail, such as HTTP GET requests. If I apply that filter, we can see everything the browser requested. Display filters are one of Wireshark's most powerful features. There are thousands of fields that you can use to isolate traffic in ways that just aren't possible anywhere else. Well, that's all the time we have for today. If you want to learn more about packet capture, you can find help in the Wireshark User's Guide and on the wiki. For help on using display filters, see the User's Guide and the display filter reference. Thank you.